Hello, this video I'm going to go over some factoring when a does not equal 1. So in all previous lessons we went over factoring when a did equal 1. This one's a little bit different. So there's actually two different ways that you can kind of do this. One way will always work, one way only works some of the time, but makes your life easier, okay? And the way that makes your life easier but won't necessarily always work is factoring out a GCF, okay? So if you look at this quadratic right here, you should be able to notice that every number here is a multiple of 3. And what that means is that you can actually divide all of these numbers by 3 and pull a 3 out in front. So this is kind of like we talked about a GCF with a equal to 1, but we were pulling the x out if there wasn't a c term. This time we can't pull an x out because this doesn't have an x down there, but we can pull a number out since now we have a number in front of x squared. So if we pull a 3 out of everything, we get left with x squared plus 2x minus 8. And now we can factor this part, all right? We can ignore the 3. So now it's just become a normal factoring problem like we did last week. And if we find what multiplies to make negative 8 and adds to make 2, it is plus 4 and x minus 2. And so that's how we can kind of do this. Now, this obviously won't always work if every single number isn't a multiple of the same thing, but this will make your life easier, so you should kind of look for it, okay? The second way that we're going to learn, I'm actually going to kind of lead you down a little path here. I would recommend trying this worksheet on your own. I tried to structure it so that you were kind of like learning stuff as you went, and that it could be done self-paced, but for this video, obviously, I'm just going to kind of go through it. So I'm trying to factor this quadratic, 2x squared plus x minus 6. So I solve my riddle, and I get x plus 3, x minus 2. So is that correct? Well, 3 times negative 2 is negative 6, and 3 minus 2 is 1. So seems like it works. Use the distributive property to multiply the parentheses and see if I'm correct. So we went over the distributive property last week. You multiply here, that's x squared. Multiply here, that's minus 2x. Multiply here, that's plus 3x. Multiply here, that's minus 6. We add those together, we get x squared plus x minus 6. So was I correct? No, I actually was not correct, because what about this? All right, there's a 2 out in front. I don't have a 2 out in front. So what did I do wrong when trying to factor my quadratic? I did not take into account I did not do anything about the 2x squared. So this is a common mistake, all right? But now that we have an a value out in front, notice what makes this term, right? It's this x being multiplied by this x, right? The x times the x makes the x squared. So now we need that to actually equal 2x squared. Okay, so what do we need to do? Well, we need to add a 2 in there somewhere, right? So we're still trying to solve our riddle, all right? We're still trying to find what multiplies to make this, except now they're not going to add to make this. One of the numbers has to be multiplied by 2. So I found all the possible answers to this problem, all right? There's a lot more combinations now than there were before, because now we've got this 2 out in front. So should the 2 go here? Should the 2 go here? You know, what should be positive? What should be negative? This is kind of, a harder problem. There's more possibilities. And I know this is a lot, but I actually want you to go through all 8 of these and multiply them all out. That way you can get a sense of what is actually going on in these problems. I think by doing the distributive property, you'll see what's going on. I'm going to do the first one, but I want you to finish it, okay? So if we do the distributive property here, we've got 2 times x, that makes 2x squared, okay? That's a good start. Then we've got 2 times negative 2, that's negative 4x. Then we've got 3 times x, that's plus 3x. We've got 3 times negative 2, that's minus 6. So notice the only thing that's different here is this term right here, right? Because this 2 got multiplied by this 2. So it's not just minus 2x, now it's minus 4x. Okay, so that does change things. So now we've got 2x squared, negative 4x plus 3x, that's minus x minus 6. So was that correct? No, I need it to be plus x. All right, so you kind of think about, okay, what needs to be different then, right? So I want you to go through all 8 of these and multiply them all out, all right, and tell me the answer. How could Mr. Mays have eliminated some of his options without needing to multiply them all out first? Well, there's some things, and hopefully you've paused the video, all right, and went and done all 8. If not, you should need to do that right now. But there's some things that you can kind of look for, okay? We know, for instance, that our b term is going to be positive, okay? So you kind of know, right? Here we got a b term that's negative because 2 times 2, that's negative 4, right? And negative 4 is bigger than 3. So we know that b term is going to be negative. So you can kind of go through here and determine which ones would work. So this one, 2 times 2 is 4, negative 3. That one would work. 2 times negative 3 is negative 6. That's going to be negative, so that one would not work. 2 times 3 is 6. That one would work. We come down here. 2 times negative 6, that's negative 12. That one's not going to work. This one would. This one would. 2 times 1 is negative 1. And this one, 2 times 1 is 2. But we got negative 6x, so that one wouldn't work. So you can actually eliminate half of them because your negative value is going to end up being bigger than your positive value. The other thing that you can look at is D and G, actually. If you look at D, notice here, all right, what do you notice about both these two numbers? They're both 2, which actually means that this answer isn't completely factored and that you could pull out a 2. And because you can pull out a 2, that means in the quadratic here, there's actually a GCF of 2. Now, if we look at our problem, could we pull out a GCF of 2? No, because this number is 1. So we know that actually can't work. And same thing for G. Both these numbers are even right here, so that would be like 2 times x plus 3. And again, that wouldn't work because we know we couldn't pull a GCF out in our original. So there's actually only 2 answers really that could possibly work, B and F. And if you actually look at it, okay, 2 times 2 is 4, 4 minus 3 is 1. Here, 2 times 6 is 12, 12 minus 1 is 11. So we know B's not going to be 11. B is actually going to be 1, so B was actually correct. So it's actually the first one that you guys did. But that's what you can things you can kind of look for. So you can look for positive or negative B terms and GCFs. All right, so you don't want to pick an answer where it would end up being a GCF. So you don't need to check the ones where the 2 here is with another even number. But if you can't remember that, that's fine. Number 6, list out the possible answers for factoring the quadratic. 4x squared plus 6x plus 7. So this one's interesting because we know our numbers still need to multiply to make 7, right? And there's actually only 2 choices, right? 7 and 1. So we know that we're going to have 1 and 7, or 7 and 1, right? But what's different here is that we actually need to multiply to make 4. And there's two ways to do that. So we could have 4x plus 1 and 1x plus 7. We could have 4x plus 7, 1x plus 1. But we could also, another way to get 4 is with 2 and 2. And actually, we don't really even need this one because 2x plus 7, 2x plus 1 is the exact same thing as 2x plus 1, 2x plus 7. So this is actually redundant, okay? So we actually don't need that one. But so again, this can show you why these can be a little bit tricky. Do we want it to be 4x times x, making 4x squared, or do we want it to be 2x times 2x, making 2x squared, right? And so, again, you can go through your distributive property here, and you can figure it out. 4x times x, that's 4x squared. 4x times 7, that's plus 28. 1 times 1, that's plus 1x, and then 1 times 7 is plus 7. Our middle term, 28x plus x, that's 29x plus 7. So this one's not correct, right? Because we want the middle term to be 16. Our middle term got 29, so that one's not correct. So you guys can figure out, is it B or is it C? And then the bottom, just factor the quadratics, okay? So the way that you're going to do this, okay, is you're just going to kind of go through. You're going to look at each one, and you're trying to figure out the puzzle, okay? We know this number at the end is -5. The only two things multiply to make -5. -5 and 1, or 5 times -1. We also know that we've got a 3 out in front. The only way to multiply it to get 3 is 3 times 1. So we know in our answer, we're going to have 3x and we're going to have x. So really, you just need to pick between these two choices, right? We know this is going to be a negative. So we know that we want our negative number to be bigger. So again, I'll just talk out loud. So I'm trying to get -2. I don't want the 3 to be multiplied by 5 because that would make 15. And that's going to be way too much. So I need the 5 to probably be here and the 1 to be here. And I need it to be negative. So I don't want the 1 to be negative because if it was like this, right, 3 times -1 is -3. That'd be 5 minus 3, which would be +2. So I want actually this one to be negative and this one to be positive. 3 times 1 is 3. And then that's -5x. So that would make -2x. And that's what we want. Okay, so the answer to this one ends up being 3x minus 5 times x plus 1. So you're going to kind of do that for the rest. I'm not going to show you all these answers, all right? You can look at the key later, but I want you to, try these out, all right? If you need any help or have any questions, just let me know. But give this a shot. Good luck and have a great day.